This time we're working with exponential equations, and I have a post-it note with me because I'm going to carry this to each and every one of the equations that I work with today. So number 1 says, get the bases the same. Number 2 says, set exponents equal to each other. And then number 3 says, solve for x. Excuse me. So we're going to work with this equation here. Get the bases the same is my first step. Here's an exponent, so this is my base. So I know that I'm going to end up using that as my base. So I have 5, and I want to get this to have a base of 5. And I know that 5 squared is 25. That became this. Step 2 says, get the exponents equal to each other. So I'm going to make this equal to this. Add 2, x equals 4. Solve for x, done. All right, let's take a look at another one. So I have 9 to the power of x minus 4 equals 81. Step 1, get the bases the same. Here's my exponents, so this has to be my base. So I have 9, x minus 4th. I need to make this with a base of 9. I happen to know that 9 times 9 is 81. So my base is 9 and my power is 2, or my exponent is 2. Get the bases the same, set them equal to each other. That's step 2. Solve for x. Add 4. Whatever I do to one side, I have to do to the other. So x now equals 6. Let's take a look at a third problem. This one's a little bit different because we're involving a fraction here. But my first thing is to still look for the base of my exponent. So this is a base because here's my exponent. So I know that I want this to equal 7 as my base over here. So let's see. I know that 7 times 7, or 7 to the second power, is 49. But this is in the numerator, or the top of a fraction, and it's written as a whole number right now. This is in the denominator. I need to get this up here. So I need to do the reciprocal, or the opposite. So I'm going to move that by making it a -2. Okay, so my bases are now the same. So step 2 says I can set my exponents equal to each other. In this case, I already solved for x. So I have completed all of my steps.